Let's take a look at relative motion. So it really depends upon the observer. How fast an object moves depends upon who's observing it. Because right now, it looks like this piece of paper is not moving to me, but if I were, say, on the moon, this piece of paper is moving because the moon's moving and the Earth is moving and the moon is not in a geosynchronous orbit, which definitely would make life a little bit boring. What we're dealing with here is two observers. So we'll call this observer A, observer B, and there's something moving along at some speed. We'll call this object C. Well, the position of C with respect to A is equal to, well, so this is x c sub A, and technically it is a vector. This right here would be the position of C with respect to B, and this right here would be the position of B with respect to A. So the position of C with respect to A is equal to the position of C with respect to B plus the position of B with respect to A. Do note that the convention here is that when I have the two subscripts like that, this is sort of the object, and this is the observer. So object C with respect to A, object C with respect to B, object B with respect to A. So if I took the derivative of each, so I take time derivative, this becomes the velocity of C with respect to A is equal to the velocity of C with respect to B plus the velocity of B with respect to A. And if I did the derivative again, so take the derivative with respect to time of all that, this becomes the acceleration of C with respect to A is equal to the acceleration of C with respect to B plus the acceleration of B with respect to A, except B and A are both standing there watching this other object move, so this is 0. So they both observe the same acceleration, which is actually rather critical for life to exist. Yeah, I'm sure I can make that argument given time. One thing to notice is that when you're doing this, that should be the first, that should be the last, and these should be the same. So if we are in three-dimensional motion, or two-dimensional motion, as you kids today say, so I have some observer A here, I have some observer B here, and some object C here that is moving at some velocity. This still holds true that the velocity of C with respect to A is the velocity of C with respect to B plus the velocity of B with respect to A. And again, I'll just make sure that those are the same. That's the one that's not included over here. And then I have C and then A. So it holds true regardless of the number of dimensions. I guess telling you that as opposed to deriving it. But it's still true. That's relative motion.